This video is for Tuesday, April 21st for calculus. So today I'm going to be teaching you about figuring out if a geometric series is convergent or divergent. So first of all, we're going to review an example of a geometric sequence because often they're represented with a sigma. So that's that fancy uppercase Greek letter E. So like this. And that looks really terrible because I'm trying to write from the opposite angle. So let me try that again. Okay, that looks a little better. So it says the summation, because that's what this means, and geometric series are adding geometric sequences together. So the summation, where n starts at 1 all the way up to infinity, and it is 1 divided by 2 to the n. So that is how it would be presented, and you could find the terms for this geometric series or sequence by plugging in 1 for n. So the first term would be 1/2, and since this is a series, you write plus, and then 2 squared is 4, so 1/4 plus 1/8 plus 1/16 plus, and it just keeps going because the upper limit is infinity, so it keeps going forever. Okay, so that is an example of a geometric series. Now we're going to look at a more generic example of a geometric series. So generically, geometric series are written like this. So the summation of n equals 0, so you're starting at 0 all the way up to infinity, and a times r to the nth power. So the r here is our ratio. So do you remember when we talked about ratios of geometric sequences and series? Well, this ratio is what you're multiplying by each time to get the next number. Okay, and so that is going to be our ratio. That's going to tell you if something converges or diverges. And then a, that's going to be involved in a formula in a minute. Okay, so to get the first term, that would just be a, because if you plug in a 0 for n, r to the 0 is 1, and 1 times a would be 1. Okay, the second term would be a times r. The third term would be a times r squared, all the way up to a times r to the n. Okay, so that is how they are generically written. Now, theorem 9.6 says convergence of a geometric series. So you have this basic setup here, and then if it's convergent, you'll use this formula, and that only works if the absolute value of your ratio, your r, is between 0 and 1. So if your ratio, which is right here before the exponent of n, if your ratio is between 0 and 1 when you take its absolute value, then that means the series converges, and you'll use this formula to figure out what it converges to. Okay, so I'm going to show you how. Alright, so we have example 1. Okay, and we have this geometric series. So n starting at 0 to infinity, 3/2 to the n power. Now we're going to rewrite this because right now it's a little confusing as to what your ratio would be. So I'm going to rewrite this to be 3 times 1/2 to the nth power. And that's totally allowed because that represents the same thing. Okay, so in this scenario, 3 is the a value, 1/2 is the r value, and since r is between, the absolute value of r is between 0 and 1, because it's 1/2, then that means that this series is going to be convergent. So I'm going to write that down here, convergent. Okay, so now we have to decide what does it converge to. So do you remember that formula that I said we were going to use? Well, we're going to use A over 1 minus R to figure out what it converges to. So A was 3, and R is 1/2. So 3 minus 1/2, or not 3, sorry. I've been in this house too long. Okay. So 1 minus 1/2 is 1/2. So 3 divided by 1/2 is going to equal 6. So this series is convergent because the ratio, the absolute value of the ratio, is between 0 and 1. And then you do this formula to figure out what it converges to. Okay, so that is the first example. Alright, example 2. We have a summation starting with n equals 0 up to infinity of 3 over 2 to the nth power. Now, you might be saying, I don't see a number in front of this, so how do I know what a is? Well, if you do not see a number in front of this, it's implied that it's a 1. So your a would be 1. But our r is this number right before the exponent of n. And because the r, the absolute value of r, is greater than or equal to 1, because 3 over 2 is equal to 1.5, since 1.5 is greater than or equal to 1, we're going to say that this series is divergent, or it diverges. And then you don't have to do the formula because it diverges. That means it doesn't have a limit, it doesn't approach a limit, so it diverges. Okay, so what your homework is going to be for today, if you open the doc that's the notes, it's at the bottom of the notes, and I put some instructions there, and I'm going to read them to you. Determine if the series converges or diverges. If it converges, meaning r, the absolute value of r is between 0 and 1, then you have to do the formula a divided by 1 minus r to determine what it converges to, and you're going to round your answer to the nearest tenth. That's important there. Round your answer to the nearest tenth. Okay, so if your r, the absolute value of your r, is greater than or equal to 1, it diverges. So if your r number, the number right before the exponent of n, if the absolute value is between 0 and 1, you say it converges, and then you do the formula. If your absolute value of the number right before the exponent of n is greater than or equal to 1, you write it diverges, and you move on with your life. So I want you to write your answers on a blank sheet of paper, and then take a picture of it and email it to me. And I put my email address in the instructions on Google Classroom. Okay, so if you need any help with that, please let me know. Send me an email, send me a message, and I'll be happy to help you. Okay, so that is how you determine if a geometric series is convergent or divergent. So stay tuned for tomorrow. I'll see you then. Bye.